So today we're going to talk about taking measurements. In science, measurements are key to experimentation, and we want to focus on taking quality measurements. So we want to take quality measurements. Measurements can be divided into four different categories: accurate, precise, both accurate and precise, and neither accurate nor precise. Um, Accuracy and precision are words that are generally used together, but there is a difference between accuracy and precision. And the difference is that accurate means correct, whereas precise means reproducible. And so, to explain that idea a little bit further, I want you to imagine shooting an arrow. If you're standing aiming at a target downfield, you could have one of four different types of results. You could be neither accurate nor precise, and that's what this picture here shows, in that you have a grouping of hits, but none of them are in the bullseye. You could have accurate, but not precise, which is this next picture. If you average where those hits are, you would be in the bullseye, so that would be accurate. You could have just precise, which is this next picture here, where you have a tight grouping of shots, but they're not in the bullseye, so it's not accurate, but it is precise. And then you can have both accurate and precise, which is this picture here, where it's a tight grouping of shots and it's in the bullseye. Whenever we take a measurement, there is always some uncertainty in that measurements. All measurements carry with them a certain degree of uncertainty, and that degree of uncertainty is based on the instrument that you use. So if you imagine measuring a certain amount of liquid, like in this picture here, what you would have is you would take your measurement, and there would be an estimated value in that measurement. So in this here, it looks like it's about 10 milliliters. That estimated value is the last digit in that measurement. So 10.0 milliliters, it's that 0.0. For non-digital instruments, the uncertainty is always 1/10 the smallest division of your instrument, and that is your estimated value. So what that means is that the selection of the measuring tool is key to both the accuracy of your measurement and your precision. So we have here a picture of the same volume of liquid in two different measuring tools, a graduated cylinder and a beaker. The first one would measure 33.8 milliliters plus or minus 0.2 milliliters. The smallest division is 2 milliliters, so 1/10 of that is 0.2. Whereas the second one is 35 milliliters plus or minus 1 milliliter. So what that means is the larger the uncertainty, the less accurate and less precise. For digital devices, the last digit is the estimated digit. So if you look at this balance here, the 1 is known for certain, the 5 is an estimated digit. Okay, so that could be something that would round to 15. Whereas in this balance, which is a little bit better balance, the 15 is known, but the 0.1 is estimated. And then in this third balance here, the 15.1 is known, but the 0.03 is estimated. So as the devices get more and more precise, our measurements get more precise. And the digits in a measurement are known as significant figures. The more significant figures, the more precise the measurement. So the first balance has 2 sig figs, the second one has 3, and the fourth one has 4. If we go back to the volume measurement we did earlier, the first one had 3 sig figs, the second one had 2 sig figs. Okay? And the concept of significant figures enables us to express the precision of our measurement. They tell us how good our data is. And what we're going to do in the next part is we are going to learn how we can determine how many significant figures are in a number.